Okay, so we're going to talk about quadratics. Quadratics should be something that is not new to you, because this should be something that you have seen before in grade 10 at least. So a quadratic function, as you guys probably remember, it's a function that has a U-shaped graph, either opening up or opening down. And then we talked about in the previous lesson that it has a degree of 2. So when you're looking at the function, it has a degree of 2, okay? So what we're going to do today, we're going to first examine the different key features of a parabola. Parabola is the name of the shape of the quadratic function. We're going to examine different features of it, and then we are going to look at transformations, okay? So how does a graph change when I change the value of a, for example, into my quadratic function, okay? So first we're going to look at some key features. So a quadratic relation is modeled by a smooth, symmetrical curve known as a parabola. Okay, so the name of it is called a parabola. So as you can see, a parabola is a smooth, symmetrical shape. You guys know what the word symmetry means, right? So technically, if you remove the odd features in the face should be symmetrical. Our face is not symmetrical, right? But a face should be symmetrical, right? When you're talking about a butterfly, if you cut it in half or if you draw a line in half, that's a symmetrical shape. Left side is the same as the right side. So a symmetrical shape is a shape if you actually draw a line or cut it in half or fold it, they're going to have to overlap. They will overlap on top of each other, okay? That's what a symmetrical shape means. We see that with a parabola. Now, when I graph a parabola, it has a few different features: the zeros, the y-intercept, the vertex, and the axis of symmetry. Okay? So we're going to start with the zeros. When I say zeros, I mean when the graph intersects the x-axis. Okay? So this is my parabola. This is the x-axis, and this is the y-axis. So how many times do you see this parabola crossing the x-axis? 2 times, right? So that means this one has 2 x-intercepts, okay? Or 2 zeros, okay? So the zeros are the same thing as saying the x-intercept. So it's when the graph intersects the x-axis. So the way we write the x-axis, no matter what they are, so the x-intercepts, we write them like this. So there are 2 points. Point 1, we write it, let's say the value of it is 2, 1, 3, -1, whatever it is. So we're going to represent it with the letter R, 0. And then we're going to represent the second one with the letter S, 0. And then later on, I'll tell you why we're using these letters, okay, R and S. Okay, so let's say in this case it's a -1, let's say, and this one looks like 3, right? So the way we write it as -1, 0 and 3, 0. This is how we represent the x-intercepts. Okay? There's another way that you can write it. You can write it you can write it as x-intercept equals to R, comma, I just want to write and, not comma, and S. Okay? So these are two different ways that you can represent the x-intercept. Pick one and stick with it. Whatever one you feel more comfortable with. Okay? So in this case, you can write it either like this. Or you can write it as x-intercept equals -1 and 3. It's okay. Yes, retirement. Oh, that's for...
Just quickly sign it, just because I have to bring it to her soon. Sorry, Maya.
Okay, no problem. So you guys have to pick one of them, okay? All right, so we talked about the x-intercept. Now we're going to talk about the y-intercept. Okay? The y-intercept, again, is when the graph intersects the y-axis. Okay? So how many times does the graph intersect the y-axis? One time, right? So we see that it's intersecting the y-axis right. Yes? That's when the graph is intersecting the y-axis. How do we write that point? We write it in terms of, you can write it, again, two different ways. You can write it as a point, and then that would be whatever that point is. So 0, C. We're going to call it letter C. And again, I'll tell you why later on. Or you can represent it as a y-intercept equal to, and then whatever the value is. Okay, so in this case, the y-intercept looks like it's at -4. So I would write it as 0, -4. Or I can write it as y-intercept equals to -4. Okay, you guys get to pick whichever method you would like, you would prefer. Are we okay with that so far? Now, we get to the vertex. The vertex is a very special point because that's the point where your graph turns. Okay? So if your graph was decreasing, then it starts increasing, or it was increasing, then it decreasing. So it's a point where your graph turns. So this is the vertex, and this is the vertex. It depends if you have opening up or opening down. Okay? So your vertex could be either a maximum point or a minimum point. Okay? So in this case, it's a maximum as it opens down, and it's a minimum as it opens up. So we call that the lowest or highest point of the parabola. And since it's a point, it has to have two values, x and y values. Okay? So, and then the letters that we're going to use to represent the vertex is h and k. Okay? So hk, where h is the x value and k is the y value. Again, there's a reason why we're using these letters because with quadratics, there's 3 different formats that we use. We use 3 different formats. So we have the standard form, the the standard form, the vertex form, and the factored form. And these three forms have different letters in them, and this is where these letters come from. Okay? We'll talk about them later. Can you grab a different chair, please? All right. Now we have the axis of symmetry. The axis of symmetry is very important because this is, we said that a parabola is a symmetrical shape, right? And the axis of symmetry is what defines that symmetrical shape. So if I'm going to ask you to graph an axis of symmetry here for me, how would you graph it? So where would you graph a line that cuts your graph in half? That passes through the vertex, right? So you would graph something that looks like this. Yeah? Right? This is how you would cut the graph in half, correct or no? Yeah. So we call that the axis of symmetry. It would equal to the value of the vertex. So let's say your vertex is like hk, right? So whatever h is, that is the same thing as the axis of symmetry because it passes through that point. Okay? So the axis of symmetry has an equation of x equals to h. Okay? So in this case, it looks like your vertex is at, I can't see properly, but it looks like it's at 1 and negative 6, right? So that's your vertex, 1 and negative 6. Okay? The axis of symmetry is passing through that vertex, so the axis of symmetry is going to be x equals to 1. So your vertex, if you see it right here, the vertex is at 1, negative 6, yeah? Okay? We know that the axis of symmetry passes through the vertex, right? So because it passes through the vertex, it's going to take the value of that vertex, okay? And it's going to be the same thing as the x value of the vertex. So it's going to be x equals 1 in this case, okay? And that's why we say x equals to h, because h is the x value of the vertex. So the axis of symmetry, it's an imaginary line. Of symmetry. That runs vertically through the vertex. So you're going to have to be able to identify these key features. You're going to have to be able to use them, utilize these key features, so you can create the equation of the graph. Okay? Or if I give you an equation of the graph, you should be able to identify all these points so you can graph your quadratic function. Okay? So it's going to work either way. Either I'm going to give you a graph, and then you're going to be able to identify them and find the equation, or I'm going to give you an equation. You're going to have to find the information and graph. Okay? Now, we still have what we call the optimal value. Now, can you guys help me? What does the word optimal mean? Hmm? The perfect, the biggest, the smallest, right? The optimal. So these are your you can't go beyond that, okay? It's either the maximum in this case or the minimum in the case of a quadratic, okay? So the optimal value means the maximum value or the min. It depends on your graph. Let's look at the first graph. Do I have a minimum or a maximum? Minimum, right? And in this graph, we have a maximum. And then you would write it like this. Y equal to the k value. Now, that minimum or maximum happens at the vertex, correct? Right? So if you look here, this value right here of the vertex is the value of your minimum or max. So the y value, if you look right here, the y value is the value of your minimum or your maximum. The y value of the vertex. Are you guys okay with that? So let's look at this. If your vertex is, for example, 2, 3, if that's your vertex, what would be your maximum value? 3. It will be, if I say you have a max, it will be y equals to 3. Okay? So that value, that part of the vertex is going to be your maximum value or your minimum, depending if it's opening up or opening down. Okay? So once you find your vertex, you can tell what your axis of symmetry is because that's the x value of it. And you can tell what your optimal value is because it's the y value. Okay? So the vertex tells me, other than the vertex, tells me two different things, the axis of symmetry and the optimal value. Are we okay with that? In terms of y value. Terms.